Hello, I'm Arpit and I'm here today to talk about provenance widgets. Consider this rain slider one often encounters on the web. If I interact with it a few times, after a point all I can tell is that my current selection is 65 to 75. Now consider this enhanced provenance widgets rain slider. As I interact with it, it keeps track of all my interactions and presents them visually as dynamic bar chart overlays. So in this same final state, I can now get a lot more information. Taller bars mean more frequently selected ranges. Darker bars indicate more recently selected ranges. A bar with a solid border indicates the current selection, whereas a bar with a dashed border indicates the previous selection. This is what we refer to as the aggregated summary view. I can also review the historical sequence of my selections, or essentially how I reached my current state from the initial state. Let's take a look. So we designed this footprint icon next to the widget that helps toggle between the default aggregated summary view and a detailed temporal history view. This view contains a point line chart showing all selected states between the initial state of 0 to 100 at the top and the current state of 65 to 75 at the bottom. And color is once again mapped to recency. So we have these three views that can be identified with and toggle between by clicking these footprint icons we designed. By the way, these overlays are interactive, as in if I hover on them, a tooltip shows additional details, and if I click on a bar or a point, I can go to that state again. ProvenanceWidgets treats this as a new state and appends it to the provenance logs. As you can see, the newly added range at the bottom. All in all, we developed such provenance overlays for single sliders, rain sliders, radio buttons, checkbox groups, single selects, multi-selects, and input text. Our motivation was that there is currently no front-end library of UI controls that tracks and presents such provenance information out of the box. So we followed a three-step design process wherein we reviewed different UI controls, conducted design exercises before finalizing everything. First, we reviewed various aspects of UI controls. For instance, structure-wise, all elements of radio buttons are always completely visible, unlike drop-downs, which require an additional click. Next, layout-wise, sliders can be oriented vertically or horizontally, unlike drop-downs, which are oriented horizontally. Next, with respect to initial or default values, radio buttons can have an uninitialized state with no selections, unlike sliders, which generally have the handles preset to some default value. Next, with respect to subsequent values, checkboxes can have multiple selected values, unlike radio buttons, which can have at most one selected value. Finally, to interact with these widgets, for sliders, one generally drags the handles or clicks on the rails, whereas for radio buttons, one directly clicks on an option. So after this review of UI controls, we conducted design exercises wherein we explored what metrics to log as provenance and when, and where and how to present them. First up, what? We chose to track and visualize two metrics, the frequency and recency of selections, because of their utility and relevance to provenance tracking and also effective visual encoding. Next, in terms of where to present provenance, we considered always visible visual sends that are near, on, or around the widgets, or more on demand, potentially in an external view. Next, in terms of how to present provenance, we sketched different combinations of marks or chart types, such as area, bar, and line, and visual encodings, such as color, size, and position. Finally, in terms of when to log provenance, we considered two kinds of analytic time. Every user interaction, or more specifically, whenever the widget's state changes, or every second. Check out this temporal history view for a single slider. For the same sequence of interactions, the interaction mode on the left shows the points evenly spaced out, unlike the time mode on the right where things are more uneven. Finding utility in both, we chose to support both. So eventually, we finalized these designs while balancing for several aspects such as consistency and ease of development. Implementation-wise, ProvenanceWidgets is built on top of the PrimeNG framework and the NGX library. and architecture-wise, ProvenanceWidgets follows the Model View Controller or MVC design pattern. For a developer to implement a ProvenanceWidgets range slider in their own application, they must still write some TypeScript and HTML. In particular, define the variables corresponding to the slider's range, a function that listens to the selection events, other options such as the step size and the HTML DOM element. The cool part is that except for the highlighted Provenance slider wrapper component, everything else is native to and inherited from the base library APIs. Thus, by default, all provenance tracking and overlaying is out of the box, while enjoying the other benefits of the base libraries. Let me show some use cases. First, widget to visualization, wherein we update a visualization based on interactions with ProvenanceWidgets. Now, consider the scatter plot showing life expectancy and fertility rate values for different countries, and a control panel with two widgets on the left. If I modify these widgets to filter the visualizations, the widgets will rightly leave a trace behind. Now, to program this behavior in TypeScript, we first define a function, widgetUpdated, that filters the scatterplot based on the input model value. And then in the HTML, we bind the selected change event listener property to this widgetUpdated function we just defined. And that's it. Next, visualization to widget, wherein we can supply provenance externally to then update the widget. Now, this could be any relevant interaction or from external libraries such as track. For example, consider another scatterplot system, this time with acceleration and horsepower from my favorite and hated cars dataset. Essentially, if we brush the visualization to select a certain range of points, we can capture the brush extent and overlay it onto the widgets as well. Now, to program this in the HTML, we override the provenance property by mapping it to a model variable, say acceleration. Then in TypeScript, we define a function, for example, VIS', that captures the brush events in the visualization and appends it to the data property of the acceleration provenance model. We also set the revalidate property to true to refresh the visualizations. Using ProvenanceWidgets, we were able to replicate the core functionalities of three kinds of prior widgets: centered widgets, phosphor objects, and dynamic query widgets. Centered widgets are graphical user interface controls enhanced with embedded visualizations that aid navigation. To replicate these, we override the provenance property with some static data, for example, historical usage logs, and set the freeze property to true, which will literally freeze provenance tracking and always show the preset data. Next, phosphor objects. These show the outcome of any change in the widget's state instantly via an afterglow effect, essentially the current selection and the previous selection. To replicate these, we once again override the provenance property, and with each interaction, keep slicing out provenance history except for the current and previous points. For our evaluation, we conducted expert case studies with 4 developers. We tasked them to develop a Pokemon Explorer system using ProvenanceWidgets. Our study protocol included an onboarding interview to explain the task and share resources, about 1 week time to work on the task, and an offboarding interview to share the developed systems and feedback. The overall feedback was positive. So at this point, I would like to invite the community to use our open source library to integrate provenance tracking into your next projects. Install it using npm install provenance-widgets. Notably, the library is framework agnostic with both Angular and web components available for broader usage. And for detailed documentation, showcase, and starter code, go to provenancewidgets.github.io. And of course, please read our paper for more information. And a big thank you to the team, Kaustubh Odak and Endert from Georgia Tech, and El-Assady from ETH Zurich. Thank you.